Options on futures contracts. Well, again, you notice the form of this call formula is, once again, this looks like the prepaid forward for a delivery of K. Right? That's new, not new. And this is the prepaid forward on a futures. I discussed this in another module, but just to be clear, let's say that I have a futures price today. The futures price on gold is, say, $800. And I go long one futures contract. That requires me to buy gold in, say, 2 months. The price I'm going to pay, F0 is 800, but when I accept delivery in my gold futures contract, I'm going to pay FT. And let's say it's 950. If I accept delivery, I pay 950, that's the futures price at that time, but in my margin account, because I was long, I have a $150 profit. So if I go long a futures contract, I am assured that I can take delivery for a net $800 price, 1 ounce of gold. The futures contract delivery will be at $950 or some price, and my margin account will bring me back to the 800. What about a prepaid? What if I, instead of entering into a long futures, I wanted to enter into a long prepaid futures? I wanted to pay right now and then simply take delivery at time T. Well, what would I pay? The claim is I could pay 800 e to the minus RT. For that many, that's all I would need. Because what I would do is I would go a long futures contract and this T-bill. I'd buy a T-bill with a market value, a present value of 800. That's my total cost, one futures contract and this T-bill. What happens at time T? The T-bill becomes 800. The 800 plus the margin gets me delivery. So the fact that the prepaid forward on a futures is the present value of the futures can be thought through through this kind of an example. So this structure of prices we see here is really identical to the prepaid forward structure of the generalized Black-Scholes. No different. So as an example of an option on futures, here we have a 1-year futures price for natural gas, and it's being quoted at 210 per million BTUs. So we have a risk-free rate of 5.5%. It's a 1-year futures contract. So this futures contract assures me that I can accept delivery on 1 million BTUs of natural gas for $2.10. Now, it's important to note that when I accept delivery, I'm going to pay the then market price, but the margin account will bring me back to the 210. So I have a futures price of 210. It's an at-the-money option, so I have a K of 210. And so I can go through the futures prices, that the prepaid forward for the future is 210 e to the minus 0.055. That's the risk-free rate, and it's a 1 year. Similarly, the prepaid forward on the strike, it's exactly the same because it's an at-the-money option. So the prepaid forward for F and the prepaid forward for K are the same numerical value. And if we go back to the earlier formula, notice that in this formula for D1, the e to the RT terms are canceled. So in this particular example, the natural log of F over K is the natural log of 1 or 0. So that term actually cancels out in this example. But in general, the RT terms cancel in the D1 factor. And with that, we then get a call and a put. The same is equal to 19 0.77. Now, why is the call equal to the put? Let's make sure we understand this. You remember put-call parity said a long call and a short put is equal to the difference in the prepaid forward prices. Well, we have a situation where the prepaid forward prices are the same. So the difference in the prepaid forward prices is 0, and therefore it's not surprising that the put and the call are the same.